what I have here online, using my cool new thing I got, I have the PDF of the exam, and I have my little drawing tablet. And let's see if I can do a decent note taking here. If I do add notes, I've already set my ink color. I'll set my ink color. Let's see. Let's try I guess the blue is okay. No, I like purple better. Oh, so and I have blue, purple notes, purple pen, and let's see if it'll let me draw. It's not letting me draw. There we go. Oh, I have to use my pen to do the drawing. Okay, so here's the first solution here. I'm going to expand this out, and this is one thing very, very tricky about this little sign here. We've got to make sure that that travels to the outside of this expression. So we need to convert that to 4, come on, add notes. There we go, 4, there we go, minus 3 times 6, 18n. And this is the tricky part. We also are subtracting, not adding 12, because it's a minus 3 times the quantity 6n plus 4. This is an easy thing to forget about. And then we have that equal to minus 3n minus 1. Now to balance this out, I'm going to add 18n to both sides. And that will clear that up. And I'm going to add 1 to both sides. That gets rid of that. So now, on both sides, I have 1 plus 4 minus 12. I have negative 7 is equal to minus 3n plus 18n, 15n. And what does that give me? Negative 7 over 15 equals n. So that would be my solution here, negative 7 over 15. This was an easy thing to mess up. Or no, this sign here was easy to mess up because it's minus 18n minus 3 times 4. Make sure that stays a minus because I'm subtracting those two things. That's, other than that, balancing out the equation, finding the final solution. And now let's see if I can scroll down. Yeah, it lets me scroll down. And go ahead and fire off a question if you have any, and I will give you a chance for that if you have any questions about that. Okay, number 2. Another fairly easy one. No x squareds in there. The easiest thing to do here, just to get rid of any fractions, multiply everything by 8. And it simplifies everything. So let's multiply everything by 8. Gives me 4x plus 8 equals x plus 8. Now that's not looking right here. I have a 4x plus 8 gives me x plus 8. Well, let's subtract it out. We get 3x, subtract x from both sides. And subtract 8 from both sides. Well, that gets rid of that 8, but that also makes 3x equals 0. X minus x, 8 minus 8. Well, the only solution is x equals 0 divided by 3 equals 0. So that's my only solution, x is 0. And you can see that there is no other number that when multiplied by anything plus 1 gives me the same number. So easier solution there. Now comes the ever intimidating word problem. Have to think about this, and especially the part about showing our work. Let's see here. We think through this problem. Something needs to equal 335 in order to get that bicycle, because I need money to buy the bicycle. Well, so I need 335 somehow. Well, let's see here. I have $35. Okay, so I have $35. Plus, what can I do to get more money? Well, $15 each week delivering newspapers. So 15 times the number of weeks will then, if I solve for W, that means that will tell me how many weeks I have to have enough money to buy the bicycle. They've formulated this pretty simply for me. Let's check the proper word problem first. Before we crank through the solution, make sure we've set the problem up correctly. 335 is what I need. I have 35 saved. I am earning $15 for every week more. Yep, that looks like the correct word problem. Now let's solve it. I subtract 35 from both sides. Getting rid of that, so minus 35 here. That gives me 300 equals 15W. Now divide both sides by 15. 300 divided by 15. Let's see here. 300 divided by 5 is 60. 60 divided by, or 15 divided by 5, so I can just do by hand. 300 divided by 5 is 60. 15 divided by 5 is 3W. And divide by 3 now, and I have 20 equals W. 20 weeks should be the answer. But before we put that answer in, let's just check. 15 times 20 gives me 200, plus 15 times 5 gives me, or plus 5 times 20 gives me 100. So 300, if I have 20 there, and 300 plus 35 does give me 335. So yes, 20 checks. So 20 is my number of weeks. The key thing here is taking a word problem, converting it into a math equation. That's the scary part, but if you think through it carefully, think, okay, we're going to say weeks is W. What I need is that. Here's what I already have, and $15 each week gives me the 15W. Thinking through the problem with that in mind, let you formulate that, and then let the math do the rest of the work to solve a real problem. A linear problem, because I'm not getting any raises during the week. If this were a more complex problem, like I earn more money every week, that would be more complex, but it's linear. I get the same amount of money added to what I'm saving each week. I'm not spending that money, which would be more realistic. I would say a better statement of this would be, I am able to save $15 each week from the money I earn, because in reality, earning $15 each week doesn't mean you don't save all of that to go towards your bicycle. But we're assuming that in this very simplified problem that he doesn't eat, he doesn't spend any of his money, only saves it for his bicycle. He is so desperate for that bicycle. So can he survive 20 weeks for not spending any of his money? Well, if he's living at home with his grandma, she's feeding him, maybe. Now back to a system of equation that someone has given to us based on some real-world problem. All we care about is, can we find the solution given a system of equations? Now, we are required to solve it by substitution. So substitution means I can solve it for x and then plug in x wherever I find an x. Or I can solve it for y, and wherever I find a y, I plug in that part for the y. Well, because I already have been given an equation with a y equals something, let's go ahead and just do the substitution of that into that equation. So wherever I see a y, I'm going to put this. So I do 2x plus 5 times, now the quantity, minus 2x plus 12 equals 36. See how that's my substitution right there. Now, get the signs right. 2x minus 10x plus 12 times 5, 5 times 10 plus 5 times 2 plus 60 equals 36. Well, negative 8x on this side. Subtract 60 from both sides. 36 minus 60 gives me negative 24. And now divide by negative 8 equals 3. So it has one solution, x equals 3. But I'm not done yet. I need to know what is y. Now that I know what x is, now we plug in y. Y equals negative 2 times 3 plus 12 gives me negative 6 plus 12 6. So y is 6. Don't forget, when you do substitution, you have to find the values of both x and y. There we go. Now this gives us a choice of how we solve this. It's looking a little suspicious, but pretty simple. If I add the two together, my y's will turn to 0 and I'll get 6 x's. Well, that seems like the easy way. So I add them and I get 3x plus 3x gives me 6x. 3y, negative 3y plus 3y gives me 0. Equals negative 18 plus 6 is negative 12. So 6x equals negative 12, x equals negative 2. Now I've solved for x. Now I plug in into either equation what with an x of negative 2. So let's do that second one. We'll get 3 times negative 2 plus 3y equals 6. Well, that is negative 6 plus 3y equals 6. Add 6 to both sides. 3y equals 12. Y equals 4. And plug that over here. And hopefully as I use this, my handwriting will get better. So there's basically, I substitute an x. Once I figure out what x is, I substitute x into the either equation and solve for y. If I did a subtraction, I get 3y, negative 3y minus plus 3y, negative 6y equals negative 18 minus 6 is negative 24. Negative 6y equals negative 24. Y equals 4. And I would get the same value for y. So check just by plugging in or solving the equation a different way, solving for y. So now I know my solutions for x and y. Since it didn't say, this is the same as saying solve by method of your choice. This one, method of your choice, now it's a little more complicated. What choice did you have? Well, let's see here. If I get a 6 and a 6, I will be able to solve. So if I multiply this one by 3, multiply this one by 2, then I can subtract and get rid of my x's. Well, let's try that. So I'll multiply this one by 3, multiply this one by 2, and I get 6x minus 18y equals minus 60. I've got to be careful. I'm multiplying this by 2. I messed that up. 6x minus 18y equals minus 62. This looks rather odd. The same two equations, or the same two x's and y, number of x's and y's, give me different numbers. Now right away I can stop and say this is impossible, couldn't happen, so therefore there is no solution. Does that make sense? Or I could subtract them and realize I get the equation. If I do the subtraction, I can get the equation, well, if I subtract, I get 0 equals negative 60 minus negative 62 gives me 2. Since that's impossible for 0 to equal 2, then I know I have no solution. You could stop here saying, wait a minute, two things, or the same thing can't be equal to two things. But if you want to do the subtract those two and get this, this also proves that, no, this is impossible. That's not a solution. Because that would have to be true in order for this two sets of equations to be true. Finally, they're giving you something a little harder. I have to use the quadratic formula. They say use a quadratic formula, so let's plug it in. This is something that should have memorized or in your notes. The negative formula is negative b plus or minus square root of b squared minus 4ac over 2a. Whenever I have an equation that looks like this, 0 equals ax squared plus bx plus c. So whatever number is in the c, I plug in. Let's find out what a, b, and c are from this. I get, well, let's just subtract this from both sides. 5x squared minus x minus 4 equals 0. A is 5, b is negative 1, c is negative 4. All right, let's plug her in. Come over here, plug it in. Negative b is 1 plus or minus square root of negative 1 squared is 1. Now this is where I got to be super careful with the signs. 4 times a times c. Well, let's just figure out what that is. A times c is 20. Actually, negative 20. A times c is negative 20. 4 times that is negative 80. So minus a negative 80 becomes a plus 80. Over 2a, a is 5, so over 10. Well, now let's figure that out. 1 plus or minus square root of 81, which is 9 over 10. So I get 10 over 10, 1 plus 9, or 1 minus 9 gives me negative 8 over 10, or negative 4/5. This is simplified to lowest terms. This is 1. There's my solution. 1 and negative 4/5. And the order that you give it is not important. The trickiest part here is the AC is negative 80. Don't forget that sign, or things blow up on you and you get a horrible answer. So easy to mess up there. That's the trick. I'd say of the quadratic formula, negative 4 AC is the trickiest part. Recognizing 81 is 9 squared, that's just practice at remembering your square tables. You can use your calculator for that as well, square root of 81. Again, I have to use the quadratic formula, and they have given it to me clearly. Again, watch out for that negative 10. So let's plug it in. Negative b is 3 plus or minus square root of b squared, which is 9, minus 4ac. AC is negative 20. Four times it is negative 80, so plus 80 over 2a, which is 4. Well, square root of 89 is not so nice. Well, let's see, 89, does it factor it into anything? Is it a prime number? Let's see here. I don't see, I think, is 89 prime? It sure looks like it to me. I don't see any factors. It's not a multiple of 3. Yeah, I think 89 is prime. So I'm stuck with 3 plus square root of 89 over 4. Or 3 minus square root of 89 over 4. The whole thing over 4, sorry. If you want to do 3/4 plus or minus the square root of 89 over 4, to me this seems simpler than separating them out. Now, for some reason, this isn't giving me, I thought, up till now, I thought this was the same. It seems to be giving me a different test than what we had on my hard copy. So I guess we'll just have to consider this practice. I do have a hard copy at home of the actual solution. Oh, actually, no, this, maybe it is the right one. We'll see. I don't remember seeing this part. Maybe I just went over it so fast. Okay. This function has what we're looking for is a min or a max, and that the value of x is negative 4. Yeah, I guess maybe this is the right one. And what is it, a min or a max? It is a min. And it's crossing, well, we don't care about what the crossing is. All we care about is where is it increasing? Well, it's increasing on the interval from negative 4 to infinity. So negative 4, infinity, and it's not hitting either one because at negative 4 it is not, it has a slope of 0. It is decreasing, coming in from negative infinity on the left side all the way out to negative 4. Now we have a little more challenge. We have a parabola here. And we're not even worried about the quadratic equation. Unless you want to, you could do the quadratic equation and figure out some things. Or let's just solve it just from what we know. If I plug in a negative 2 here, what do I get? Well, I get negative 4, because that's 2 squared, negative 2 squared is 4, minus 24 minus 6 gives me minus 36, right? So that negative 2 is minus 36. The vertex. I have to find out where is it a minimum. Well, at this point, I have to figure out, is there a decent way of factoring it? Well, let's just do our little factoring trick here. Is there two numbers when multiplied give me 6, and when added together give me 12? I don't see any. 6 times 1, the highest I'm going to get is a 7. So don't think I can factor this. So to find the vertex, what can I do? Well, I could find where the zeros are, and it should be about halfway between that. Looks like I'd have to, unless I'm missing, oh, I'm missing something. It's -6. Is there a factor for that? Am I missing something? X. No, that's, I guess it looks to me like I got to do the quadratic to figure out, well, the y-intercept, that'll be easy. X of 0 gives me -6. This one, I need to find my zeros. And it looks like I'm going to need the quadratic formula for this one, because I don't see a easy factoring. Let's plug that into the quadratic formula. So here I need the quadratic. So -12 plus or minus square root of b squared, 12 squared, I've memorized that, 144, minus 4ac. Well, ac, -1 times -6 gives me 6 minus 24. 4 times 6 over, let's see, a is -1, so over -2. 144 minus 1 minus 24 is 120, square root of 120, -12 plus or minus the square root of 120 over -2. Well, 120 is 10 times 12, or 10 times 6 times 2, or 5 times 2 times 6 times 2. Oh, I see a 2 squared is hiding in there. So I have a square root of 30 times 2 squared. So I can make that equal to be -12 plus or minus 2 square root of 30. See where the 2 times 2 comes out of the square root. 5 times 6 is still stuck inside the square root of 30. Divide by 2 gives me 6 plus or minus square root of 30. In my calculator, then, I can figure out those numbers, round them to the nearest 2 decimal places. But the vertex, how do I know where the vertex is? It's a little trickier one. Basically halfway between the 2 zeros. So I could add these two together and divide by 2. Well, that's not too bad. 6 plus square root of 30 plus 6 minus square root of 30 divided by 2. What does it give me? Well, the square root of 30's cancel out. 12 divided by 2 gives me 6. So my vertex is at x of a value of 6. And if I evaluate it at 6, well, I get -36 plus 12 times 6, 60 plus 12, 72, minus 6, or let's see, 72 minus 36 is 36, right? Minus another 6 gives me 30. So evaluating at 6 gives me 30. So that's my vertex. It is going negative because I have a negative multiplier. I know the parabola is going to look like that because I have a negative multiplying by the largest power. I know my vertex is halfway between wherever it crosses the x-axis. 6 plus or minus square root of 30. So I know that 6 is my vertex. I had to use the quadratic formula to figure out where it was crossing 0. That allowed me to figure out my vertex. So I solved for the y-intercepts, or for, yeah, I solved for the value of x is where f of x equals 0 first, and then I came back to what my vertex was. That was probably the most complex one we have so far. These I'm hoping was pretty easy for you. The degree is just what the power is. Uh-oh, where's the power? Well, x to the 0 is equal to 1. So the degree of that term is 0. And remember, the degree of any polynomial is whatever your highest power is. And for our last problem, giving you a little relaxation from the tough one that came in that one. Question number 10. All we care about when we worry about what the behavior is at large or negative or large positive, whatever the highest degree is. There it is right there. The highest degree is 7. That determines the behavior at large values of p. Since it's an odd power, a negative number times to an odd power will be a large negative number. But we're also multiplying it by a negative 3, so therefore it will be a large positive number as I get negative p. Positive p will be a very large positive number multiplied by a negative number. We'll go negative as I go large p. So I go to negative infinity as I go to the right. I go to positive infinity as I go to the left. So therefore, left negative infinity means I'm going positive infinity. As I go to the right with large values, I go negative. Big, huge numbers negative, because I'm multiplying by the power of 7. The largest power dominates the formula as I get large values. Remember, as I get close to 0, this then becomes the dominator, because these get really small. There you have it. Going over that first quiz. Do you have any questions about that, anybody? All right, are we ready to go on and do some practice on the next section? I'll give a chance for any of you if you have questions. Yeah.
I have a general question for our final and stuff at the end of the semester. Will it be like, I know some teachers do the finals just over the final chapter, or will it be over all of these chapters that we chapter 1, 2, 3, will it be over everything combined, or how does that look?
Well, I'm basically following the same sequence that the other classes are doing, because I don't want this class to be completely different than the others.
Right.
Let me see what they have for a final. Looks to me, I'll check with Carissa. It looks to me like it's just going to be the 4th exam. I will confirm with her. I don't see a specific final listed yet.
Okay.
So it looks right now as though there is no comprehensive final.
Okay. Awesome.
I tend to go to comprehensive finals for my classes, but I want to follow what the other algebra classes are doing and not make this one harder. So it looks right now as though it's just a 4th exam.
Right.
I will confirm with that. So if I don't confirm that, remind me.
Will do. Thank you.
Okay, so let's start looking now at compositions of functions. Let's go ahead. I'll bring up the text and walk through it, and then maybe get started on some of the worksheet. I'll give do I have a worksheet yet for 3? I'll make up a worksheet. Right now, we'll go through the text and walk you through what we have there in the text for algebra composition. So I'm going to bring up that page. Well, that really went weird. Let's try that again. There we go. composition of functions. So we've looked at functions and solving for them, but as we use different functions, or as we do different, present with different problems, often problems become a combination of smaller problems. So that what we're planning to do is, suppose we had two problems that we could break down into smaller pieces. We're planning on that approach to a problem. So we're thinking of it one way. Suppose I could have a problem, this function t. Suppose I could say, well, it's just a combination of two smaller functions. In this particular case, I have a function, a wife's income W, and a husband's income H. And Y represents the year. Well, I've broken my total income into two smaller problems. Add up my husband's income plus the wife's income. Therefore, I can assign someone to figure out, is there a function of the husband? So the auditor comes in to figure out the total, breaks it down into two problems. They could hand to two different auditors. One solves this function. The other one solves the other function. And I messed up that. And therefore, I have broken the total income problem into solving these two. All I have to prove is that, yes, indeed, the total income is husband plus wife's and nothing else. There's no one else making money. They're not making money because of some combination, or if there is, there would be some other function in there. So now, all we have to figure out is H and W, and we've broken into a smaller problem. But mathematically, what we've done is say, okay, I can, if H plus W makes a simpler problem, then it might be easier to solve for T of Y. It depends on how it looks. All we want to be confident in is, if I have two functions, what can I do with them? Is it legitimate to add them together? Can I multiply them? Is that legal? And does it come out mathematically to give me the same answer? So the mathematician sat down and, thinking about this, if I have a function of f of x called f of x and another function of x called g of x, can I add them together? Will that all work? And how do we represent that? The two functions added together, we can just say, yes, this is true. When I want to add two functions, simply mathematically write them out and put a plus in between them. Fg of x means I'm multiplying the two together. So this is kind of the definitions of what I'm doing. If I say f over g of x, I mean this. So this table makes sense, and this is just explaining what this means. Let's look at an example now. I have the functions g. I'm being asked to come up with what is g minus f of x and what is g over f of x, giving these two functions. F of x equals x minus 1, g of x, x over 2 minus 1. Well, the subtracting is probably easiest. Let's walk through the solution. I haven't yet tried writing over things with my little pointer. Let's see if this works. No, it doesn't let me draw. I have to somehow figure out how to get into drawing mode. I could take a screenshot and then draw on it. But before we look at their solution, let's think about this. G minus f of x would be x squared minus 1 minus x minus 1. Well, the minus 1s are going to cancel out because I'm subtracting a minus 1 from a minus 1. So it will become x squared minus x. X squared minus x is x times x minus 1. So we'll have two solutions. G over f would be x squared minus 1 divided by x minus 1. Well, remember the special behavior of x squared minus 1 is the same as x plus 1, the quantity, times the quantity x minus 1. So g over f is going to be x plus 1. So I have x times x minus 1 for g minus f. X plus 1 is g over f. So no, they're not the same function. Let's see what they come up with. There they get. G minus f is x times x minus 1. G divided by f gives me x plus 1. Now, whenever I do this divide, I have to be careful. This is an important thing to specify. When x is equal to 1, I'm dividing 0 by 0. That's mathematically illegal. So I can say this is true, but when x is equal to 1, there's a special thing that happens. Things blow up if x is equal to 1. I can't, the solution of 0 divided by 0 is not mathematical correct. Although it looks like it's really close to 1, mathematically it's not defined officially as being 1. So I'm identify that if I'm going to have this be possible, everywhere that's true except for x is equal to 1. And of course, no, I don't get the same answer. G minus f is not the same as g over x. Now, I don't know why they're asking that question. They're just giving us practice at understanding this. There may be an actual solution that somehow it matters whether they're the same function. It doesn't seem like there's going to be very often that a function minus the other is going to be the same as when they're divided by each other. Maybe there's very special function. If that is true, there might be some special. Let's look at this one. F times g of x and f minus g of x. Well, let's see. They haven't given me the scratch paper. Let me see if I can. I think if I can bring up my whiteboard. That's something I have to install. Let's see. Could I draw? Let's see. Oh, I'll just bring up Paint. I'll just draw this on Paint. And I'll draw over here on the side. All right, let's see if it lets me draw. I got to turn on my pencil. Okay, so let me use my pen here now. So fg of x. So I want to do fg of x is x minus 1 times x squared minus 1. They want us to simplify it. Well, is there an easy way to simplify that? Well, I know this is the same as x minus 1 times x plus 1. And here I have an x minus 1. So it's x minus 1 squared times x plus 1. It doesn't look like it's much more simplified. I would say, unless they want me to multiply it out, to me, this is the best simplification of it. Now let's do f minus g of x. So this is f of g, f times g. Let's do f minus g. Plug in f, x minus 1. Subtract g, x squared minus 1. Well, this comes a little bit simpler. The minus 1s cancel out. And now I have x minus x squared. Well, let's factor that x times x minus 1. That, to me, looks the best simplification of that. Although x minus x squared looks pretty good, too. If you want to put it in the exact polynomial form, if they had asked me for, give me the polynomial form, then I would have put negative x squared plus x is a nice way to write it as a polynomial, the highest degree on the left side. Otherwise, they're not clear on what they mean by simplify, because these two are still looking to be pretty simple. So unless it's obviously one is simpler, I would probably accept both answers here. Because they didn't show in the solution what was, well, no, the question was, are they the same function? And no, they're not the same function. X times x minus 1 is not the same as x plus 1 times x minus 1 squared. Now, if we start dividing things, maybe there'd be a way I could somehow make them equal. Okay, does that make sense? Again, we're just playing games with functions, and as we learn to do this, we'll discover we can solve harder problems. So the whole point of this is understanding the mathematical, the meaning of these kind of equations, and if we understand this, we can start solving harder problems. So looking at equations, putting them together into more complex things is developing your problem-solving skills. Even though you may never come across a problem in life with a function like this, as people explain to you various problems in the world and how mathematicians can model them, such as how we're predicting the cure of the COVID based on the infection rate, which no one has successfully proven the accurate model because there's so many factors. They give us some idea what to expect based on mathematics. People out there in the world are going to try to fool you with mathematics. If you have some idea of what they're doing, you can say, wait a minute, that's not mathematically correct to try to solve the problem that way. And you may catch someone trying to embezzle money out of you by understanding these problems. Now, here's another thing we want to do, and that the mathematicians want you to understand if you're learning basic algebra. A function f composite g of x. What in the world do they mean by that? Well, what they mean is, wherever you have an x in the function f, put g where it's basically a substitution. Put the function g where you had x in the outer function. So we can say it as f composed with g at a particular value x, or we call it f of g of x. This is g of x. This is f of g of x. So it's like we're substituting g of x where we had x. So remember substitution? That's really all this is. G of x at some function. Wherever you see an x in the f function, put the g of x in there. So think of another way is, I have a function g, and he produces some output. Well, feed that output of g as the values that f needs to take. So for every output that g generates, plug it into f again and see what we get. And you come up with some interesting solutions or interesting world-changing discoveries. So let's see how they would do that. Here's f of g is x plus 2. So we take, and then f of x is x squared. They gave us simple ones. So f of g means square x plus 2, because that's what f of x does with whatever it's given. So f of g of x means take x plus 2 and square it. And so now I can solve a different function and call it h of x is x squared plus 4x plus 4. Sometimes you can go the other way and you realize my problem I'm trying to solve is actually f of x plus 2. And if I know something special about f, I can say, well, when f has given x plus 2, I know that that's what to do with f. And when x plus 2 has a certain value, I know f blows up or f does something. I can solve a problem going the reverse direction, recognizing I have a composite function. So knowing what they mean by f of g of x is what we need to be comfortable with here. We have g of x, some function. When you see this, don't panic. Just say, okay, whatever g is, I plug in what I did with x before. I square it. Crank out the multiplication, the FOIL, first, outside, inside, last, and I solve for that. G of f of x gives me a different answer. I take whatever I've given here and add 2 to it. Well, if I'm given x squared, then I just do x squared plus 2 is g of f of x. Now, there may be a time that f of g of x is equal to f of, or g of f of x, but that will be for some special event. And something they mentioned here too is that the output of the function that's inside of the f becomes the input for the outer function. So that what they're saying is here that the range of the inside function, that means the output that the inside function gives you, becomes the domain of the outer function. So if the range of that input function, it violates the possible inputs for the outer function, then things blow up. So you better make sure that that function that you're putting inside the other one doesn't give you a value that causes the outer function to blow up or to not be give you a possible solution. For example, suppose g were square root of a number. The g is the valid domain for g. If g is square root of x, f of x must only, I'm only valid when f of x has given me positive numbers. So if f of x ever happens to be negative, g blows up and gives me imaginary numbers, which is not allowed in normal physics. So the range of that becomes if this does not take all possible real numbers. So again, the rule is the composition of two functions is take the function g, put it inside the function f. That's the composite. The domain of the composite function f has two requirements. The range of g is in the domain of f. The range of g's output is the input for f. And remember, the multiplying the two functions together is not the same as the composition of the two functions. So now we've got to apply some very basic mathematics to this. Is it possible that f of g of x, if I take f and feed g into it, is that the same as taking g and feeding f into it? Well, let's try it with some very simple functions. And before we look at the solution, let's think about this. If f takes its number and it multiplies it by 2 and 1 to it, is that going to be the same as, and then I put 3 minus x in there. So I multiply 3 minus x times 2 and add 1 to it. Is that going to be the same as if I take any number and subtract it from 3? Am I going to get the same thing if I feed 2x plus 1 into that? It sure has a feeling that they shouldn't be the same. Let's find out by this particular example. So feeding, oh, why wouldn't it show me the solution? It's making me log in to see the solution. Are we going to have to show the solution ourselves? Try this one more time, and then I'm going to have to do it myself. What happened here? Did it log me out? Well, it showed me for a second, and then kicks me out. There, it finally showed me. Okay, so let's substitute. 3 minus x where x was in f of x. So see, I take that 3 minus x, put it right there. Okay, I get 6 minus 2x plus 1, 7 minus 2x. That is f of g. G of f is put 2x plus 1 where the x is here. So I get 3 minus the quantity 2x plus 1, 3 minus 2x minus 1. And yes, indeed, I do not get the same function. They are, the composition of f of g is not equal to the composition of g of f of x. Now, there may be a special time where it is equal, such as g of x is x and f of x is x. Well, composition is going to be the same because they're very simple functions. So now we have an actual solution here. Let's see here. We have a function, number of calories burned, completing sit-ups. And S of t is the number of sit-ups can perform in t minutes. See how that's a composition? Calories of the number of sit-ups in so many minutes. So there it is, a composition in an actual real-world problem. So S, number of sit-ups in t minutes. They're asking us to interpret it. What do they mean by that? Let's see what they mean by interpreting that. My interpretation would be the calories of the number of sit-ups in 3 minutes. Let's see what they say. And it's not letting me, maybe I have to click this more carefully. Or is it forcing me to answer that before it'll show me the solution? Come on, let me see this. I don't know what's going on with that. It shows me for a second and then pops that up. Then shows me that. That's just crazy. I'm trying this one more time. I don't even have an account there. Maybe I have to have an account before it'll let me show solutions. Well, I guess I'll have to skip that. It's not letting me see that unless I do a quick read it before it goes away. Yep, that was the answer. It said exactly what I said. Suppose if we recorded this, we can catch that frame. Okay, so then, well, finally, here they do interpret it. Finally, the inside expression is composition. S of 3 is the sit-ups in 3 minutes. There, simply the number of calories burned in 3 minutes by doing sit-ups. Now, this one here, let's see, what are they asking here? The function f gives miles that can be driven in x number of hours. G of y gives the gallons of gas used by driving y miles. Which of these expressions is meaningful? F of g of y or g of f of x? Boy, this is a little tougher question. F of x, miles that can be driven in x hours. G of y gives the gallons of gas used by driving y miles. This gives me based on time, right? Miles that can be driven in x hours. So this gives me miles. Well, G needs miles, processes miles, and gives me the gallons of gas given in miles. So you can kind of think of it this way, not without even thinking about the numbers. This takes miles. No, this takes hours as its input. F takes hours as its input. G takes miles as its input. Well, since F gives me miles, F can be given as an input to G. So I can have G of f of x, because f of x gives me miles. I feed miles into G. Going the other way, f of x is expecting hours. Well, G doesn't give hours. G gives me gallons. So f of g of x doesn't make sense because, or f of g of y doesn't make sense because there's no such things as miles that can be driven with x gallons. Although you could figure that out, miles that can be driven in x gallons, I need to know more than the information I have. But I can figure out if I know how many, let's see, this takes hours. This takes miles. I can get miles from X and then figure out how many gallons I've used. So this one makes sense because G gives me miles. No. X, yeah, I had this figured out. This gives miles, yeah. And I can feed that into G because G takes miles. So G of f of X is what makes sense. Let's see what they say in their solution, see if I can get that to show. F takes hours, number of gallons. So f of G is meaningless. G of X makes sense. G takes miles, F produces miles. Therefore, I can figure out G of f of X. Now, there are maybe times, depending on your definitions of your functions, when they're both meaningful. All right, now they've given us one more, and let's think through this, and then we'll do a little bit more on composite functions, just to get us thinking. Gravitational force, distance r, is given by the function g. So g gives us a force. The acceleration of a planet, subject to a force, F, is given by a. So I'm acceleration if I've fed a force. G does give me a force based on the distance from the sun, r. So I can feed G into A and figure out my acceleration towards the sun based on the gravitational force of a distance. So A of G of r means acceleration from the force of gravity at a distance r. Now, if the force came from anything else besides gravity, I could feed that to where F is. Does that make sense? G gives me a force. The function A gives me acceleration based on some force. Well, I can substitute G of r for that force, and now I have an acceleration based on a force given by G of r. So the physicists, all they care about is give me a force and I'll tell you the acceleration. I'll go do all the work to figure out on the laws of physics, whatever force you give me, I know what the acceleration is going to be. Then the other physicists can say, okay, here's the force that gravity will give to you. If I have a rocket, that will give me another force. But if you want to solve it for just based on the gravity of the force of the distance from the sun, here's that force. And then what they'll do is say, okay, I know that I have this force giving me a certain acceleration, but suppose I add a rocket to accelerate away from the sun to save us from dying and burning up in the sun. I can subtract that force with a rocket in the opposite direction and reduce the acceleration. I can feed my solution into the acceleration solution to figure out how to get the acceleration to 0 so I'm not accelerating towards the sun. So this is allowing us to solve harder problems combining smaller problems. So as we evaluate our functions, we can evaluate them at certain points. Well, at this point, let's go ahead. Well, you know what? Let's just take a look at a worksheet and see what kind of problems they're giving us based on this far through the textbook. Let's go back to here now. And let's take a look at Algebra Function Homework 3.1. So we're going to just start thinking a little bit about what we're going to be looking at next week. So I have two functions. Let's see, let me go ahead and I'll make a PDF out of this and then notate it. I'll print this to PDF, save it to my documents. I'll call it Chapter 3.1. I'll go open that. And zoom in, and let's evaluate this. Turn on my add notes. Given those two functions, f of g of 5. Well, let's figure out what f of g is. I simply add them together. X squared plus x minus 30 plus x plus 6. Well, just feed a 5 to wherever you see x. We can simplify that to be x squared plus 2x. Let's go ahead and simplify it. X squared plus 2x minus 24. Now we feed a 5 into it, and I get 25 plus 10 minus 24. 35 minus 24, or 11, right? This is f plus g. F minus g, well, let's do the subtraction. I get x squared minus, x squared plus x minus x, so the x's are going to cancel out, right? F minus g minus 30 minus 6 is going to be minus 36. Well, I know that's x plus 6 times x minus 6, but all they care about is evaluating it at the value of -4. So it's 16 minus 36 equals minus 20. F minus g evaluated at the value of -4. Feed a -4 into there.
Wait, wouldn't it be, wait, what is it? 36, wouldn't it be if you're doing?
I'm doing f
30?
minus g. So f minus g gives me x squared minus 36, because x squared plus x minus x plus 6, the x's cancel out. And minus 30 minus 6 gives me minus 36.
Oh, I don't know why I was thinking it'd be like x squared plus x minus 30 minus x plus 6. So it's still a positive.
Yes, it's minus the quantity x plus 6.
Okay.
Yeah. So you can kind of think of lining them up here and then doing the subtraction, and see that minus 30 subtracts another minus 6. F times g, well, that gets a little more complicated.
And then, wait, sorry, I have a quick question. How did you go from the x squared minus 36 to the 16?
Oh, because I fed a 4 into the x.
Oh, I see.
4 into the x gives me 16. So it gives me -4 squared is 16, because I fed -4 into the x. Now f times g of x evaluated at 2. Now at this point, I could just feed 2 into each one and then multiply it, rather than doing all the multiplying out, because all they care about is evaluating it at the value of 2. So it might be easier at this point to just evaluate each one at 2. So f of 2 is 4 plus 2 minus 30, which is 6 minus 30 minus 24, all right? G of 2 is 8. Now, multiplying them out, I get 8 times 20, 160, or negative 160, minus 8 times 4, 32, minus 192. So I don't have to actually multiply all my x's out. I can just say, give me x g of 2 times f of 2, and let me do the math later, rather than multiplying these two together, getting an x cubed in there. Oh, kind of scary. So I solved it the easy way, solving for at 2 and then multiplying. Now, if you want, you could multiply them out and prove that when they multiply and get the x cubed in there and all the others, that I end up getting the same answer. Be a lot more messy multiplying them out and getting x cubed. I'm not even going to do that in my head. I get x cubed plus x squared minus 30x plus 6x squared plus 6x minus 180. F of g, I'm going to do the same thing. I'm going to do it the lazy way. Evaluate f at -1 is equal to 1, -1 squared, minus 1, 0, minus 30. So negative 30. G of -1 is 5. -1 plus 6, 5. Negative 30 divided by 5 gives me negative 6. Or else I could just do this. I could just do the quotient x squared plus x minus 30 all over x plus 6. And I'll get the same answer, negative 30 over 5. So the dividing is a little simpler, but multiplying them out, that's kind of scary. I could always just leave them separate. I don't have to multiply them out. I could just do x plus 6, the quantity, times x squared plus x minus 30. I don't have to combine the polynomials because I just feed x, the value of 2, into there, and I get the same answer, negative 30 times 8. Or sorry, negative 24 times 8. Well, we will stop there. Read through homework 3.1. If you would like a redo, the conditions will be worked through all the lessons on chapter 2. There's 4 chapter 2 lessons down in the video lessons.
Homework 3.1, 3.2, and quiz 6 are due on the 26th.
Yep, next week we'll be looking at 3.1, 2, and 3. Be a quiz as well. Make sure that there's a quiz that's supposed to be. I'll figure out which quiz goes with that section as well.
Quiz 6.
Yeah.
Will the lumen dates will all 3 of those be due on the 26th? Then?
Yeah.
Or will it be different?
Yeah.
Okay.
All right. Have a wonderful day. I will stop the recording and then stop the presentation. The recording will